Good morning, my name's Wayne Barrow, and this is the start of my far out. This is not as easy as I thought it would be. This is the start of me wanting to look into this subject of the flat earth phenomenon. So yeah, I've spent the time, it took me a few days actually, getting this website on the go where I created a video and my first blog, and yeah, it took a bit longer than I expected, but got there in the end. I've also got my YouTube channel on the go, so that's good. What else? So I'm having to start spending money on this project, so I managed to purchase a telescope, and the idea being that I can shoot a laser beam across a lake and actually see the dot on the other side. So what I've done, I've got my laser beam here, which is basically what they call a 303. So it's got a good amount of power to be seen. You can shoot it a few kilometers and still see it. I purchased this item here, which is actually made to mount a laser inside the bracket. It's big enough to do that. And then this gets mounted where the little telescope is, the finder scope. This gets mounted in the same dovetail mount. Now my only problem is that if I just remove this here, take this out, and then, when I come to mount this, I don't know if you can see that very well. Let's come around this side, but it's a rattling, what we call in engineering, a rattling good fit. So that's not going to work. So when I took some measurements, I got a little vernier caliper here, and basically took some measurements. As you can see there, it's 31.9. But if I measure this, there we go, it's 29. So what I noticed on this one, there's a little ridge there of about 4mm that raises it up. So what I'm going to do to get this to fit into that dovetail is make a little plate, which, if you follow me through here, go through to the garage. I found a couple of pieces of plate earlier on, which are here. I've used these on another project. And they're both about 3mm thick, so they'll do. There's a steel one and an aluminium plate, but I think I'll use the aluminium. You see that's about 3mm, which is perfect. So I'll use that plate and I'll chop it up, get it to the correct size. I can actually adapt that adapter for the laser to fit it with the telescope. The reason why I'm showing you all this is because this is an experiment anybody can do, you know, with a little bit of motivation, especially with the tutorials that are available on YouTube and elsewhere, plus what I'm going to show you now. Anybody can conduct this experiment of shooting a laser across a lake and getting some sort of understanding that there should be a earth bulge that should intercept that laser beam. And I know the disbelievers have debunked it and said, oh yeah, it's cool air above warm air, or warm air above cool air. It's whatever excuse to say that the laser beam is being bent around to the exact curvature or thereabouts, so that the laser beam is it is suggested that the laser beam follows the curvature of the earth and therefore, or the curvature of the water, and therefore there's no proof that the earth is flat. And I disagree with that respectfully. I've learned not to get emotionally angry anymore like I used to. I've really ended up in heated debates with people, and it's counterproductive. It doesn't help the cause, but you know, I found that if I argue my case and stay cool, people are more likely to listen, which is the whole purpose of the exercise, is to get people to see things from a different point of view, and perhaps, you know, hopefully create a chink in their armour through which the light of reason can shine, and they can think, oh, you know, maybe you got a point there, you know, that. So yeah, what I'm going to do is to fit this laser to the telescope. And I do apologise for being a bit long-winded. It's part of my personality, and I'm not you. This is my first vlog that I've ever done, so I'll get better, you know. But bear with me. For those that are interested to carry out this experiment, this information will help you. So essentially what we're looking at is a rectangular plate. I'll try to draw it here. Simple as that. Whoops, sorry, it's moving. I'm doing this one-handed. So we've got our rectangular plate. So I'm going to take my first measurement, put my glasses on, and you can see the dovetail is 31.7. So I reckon if I make it 31, that should fit in there without an issue. So 31 millimeters. Let's write this down. 31. Okay, the other dimension that I need is that dimension there. So I'll just check that it's still calibrated. Yeah, we're good. So the plate really needs to be around about so if I make that plate about 38, I'm going to make it 38, which is 1.5 inch to those who know metric and imperial. So we'll stick to metric. Okay, so that's the size of my plate that I need to make it. What's happening with this bracket, so I can adapt the laser to the telescope, is probably typical of the problems you're going to encounter. Things are not going to quite fit or be as you expected them to be. So it's good to know somebody or have a few basic skills yourself. So I'm just, sorry guys. So I'm just going to show you how you can make this plate as an example of how you can get around problems. Works. First of all, we'll slide. Yeah, that fits in there nicely. I'll actually have that way, and then I think this might go this way, because you can see the curved design there, and then that I can use a screw on the front to help bolt that in position. And I'm hoping now we should get some. But anyway, at least it's mounted, it's solid, and it will take the laser. So I'm going to have fun mounting the laser now. So what I did, I basically reversed this. I undid an Allen screw there and reversed this, and it's got quite a nice alignment there. Now you can see the laser's nicely mounted. My next little challenge is, you can see just about there, we're making a nice little laser dot. I don't know if you can see that, but I need a little something to come down on that little button there. This is how you adjust the telescope. So I'll just change the orientation, bring it down a touch. You can see it. I'm just unscrewing it there, and that's just bringing it to a more parallel, so that when I do my beam, you'll be able to see the laser beam dot there. And so my next little challenge is, if I can get that to focus, do it this side, is I'm going to move the laser slightly up so that this button there is under this ring, and then I've got a little tap that I can drill and tap there, and then I can mount an additional screw so that when I screw it down, it will actually push on that button and it will give me my laser dot without actually having to press it every time. So that's my next little job that I'll get on with now. Okay, so you can see now, by adjusting the screw, there's the laser off and there's the laser permanently on. And yeah, so I have a working telescope, and of course with the tripod it allows you to adjust the height, as you can see there, so I can get it reasonably low. And yeah, so as you can see there, the laser looks pretty good, and I'm getting my nice permanent beam there. So I'm, you know, step at a time, I'm getting there, and it's all working good. Excellent. Okay, so I'll set the camera up out here, and as you can see, I've set the telescope up, and I'm looking. I tried to start on a tree that was way out in the distance, but I couldn't really achieve a focus on it. So what I've done, I probably can't see, but I've actually got the telescope focused on that little dot. I wonder if I can use the zoom feature here. There you go. There we go. Yeah, just above the we call it the bird bath, you can see a knot. Let's go, we're at 8x zoom there. You can see a knot. Now if I put my laser on, you can see the dot is, so I'm going to collimate it now, because I know the telescope's on that. Let's just bring the dot up, probably by loosening that and tightening these. You can see the dots moving up now, and I wonder if I could just see it in the telescope. Yes, I can. Wonderful. So I'm going to continue doing that, and the dot right spot on there. It's dead center to my telescope, so I'm going to try and pick an object that's further away now, and we'll see how we go there. It's reasonably calibrated now, so I can take it out into the field, and I've got a better chance of getting set up quickly and getting my footage and shots and shooting that laser across the lake. Okay, see you later.